So I will be talking about the concept of studio code as it relates to programmers and how we can better use it for and how we can better use it for um, great opportunities uh, in understanding problems we want to solve as programmers, right? So this presentation will be diving into essential concept of pseudocode and flowcharts, which are invaluable tools for planning and visualizing Python programs. So we'll explore their benefits and practical applications in software development. So importance of pseudocode and flow and flowcharts in Python programming. All right, so the importance of pseudocode and its functionalities cannot be overemphasized. So pseudocode basically enhance clarity. So when you are a developer, there is need for you to like have a concise representation of the program logic for which you want to create, right? And also making it easier to understand the flow of execution for what you are writing. Clarity is very key because it directs your steps. So even when you are like hooked and you want to go back, you know like where to go back to because of what you have already done. So the second one is error prevention. So by visualizing the program structure, potential errors can be identified and addressed before writing actual code, saving time and effort. Then third one is improve collaboration. So these tools facilitate communication and collaboration among developers, so ensuring everyone is on the same page. Streamlined debugging. So flowchart can help developers trace the execution part of a program, making it easier to pinpoint and resolve issues. Okay. Then moving forward, you can be able to understand basics of pseudocode syntax. So the basics is that we have like the start, so we have like the English part and we have the keywords and operations part. So on the English part, we have start, initialize variable, perform calculation, display result, and then you end the program. Then we have if condition, then else, while condition, do, for loop, iteration. So for this very one, it enable you to be able to work on it enables you to be able to when you start a program there's a conditional statement that needs to be right within, then you can initialize, then perform calculations and all. So for instance now, maybe you want to write a program to open door for a specific person that uses, and the door has facial recognition. So you need to like have a start. If then the conditional statement would be probably if um, person equals to so face, and then you initialize the variable, open the door, else tell the person to wait, then perform calculations when it needs calculations to know if it can permit the person to come in or not. So that's like the whole idea about the basics of pseudocode syntax. So then the flowchart symbols and their meaning. So the oval is used for the start and end. So I'm just going to um, take a pen. So now let's say this one. So this is an oval, this one. Then you now have the rectangle, which is for process, um, which basically is for process and action. So this one, it's rectangle. Um, Sorry, I need a pen really clean. The pen. Okay, so something like this. Sorry, this one. Then you have this one. Then diamond is this one. You have like parallelogram. Then you have arrow here. So diamond are used for decision and condition. Parallelogram is used for input output, while arrow is used for the flow of control. So um that takes us to the next point. So that being said, you now have start. So the function of the start is initializes two variables. So this is an example of a program, an example of a program. So control T, so we are writing a simple program in Python, right? So the program now is we want to add two numbers together, 10 and 20. So you said that initialize. So you are asked, okay, hi, we need you to write a program that adds two numbers together, right? Then these numbers, the first thing is you initialize two variables, num1 and num2, with their values 10 and 20. Then process, that's calculate the sum of num1 and num2 and store the variable in a variable named sum, right? Then display the value of sum to the user and the program. So this is basically the concept of pseudocode. It enables you to like write your code in a very simple format, giving you the ability to clearly understand what you are supposed to like basically do. Then the next thing is for you, the next thing to then go ahead and do. So let's look at the next thing. So the next thing are like the flowchart example. So that's for the conditional statement and loop. So for the conditional statement, we have like a diamond. So a diamond symbol represents a condition. Two arrows branch out from the diamond, leading to different actions depending on whether the condition is true or false. Then we have loop. A loop is depicted using a diamond symbol with a circular arrow connecting back to itself. The loop continues as long as the condition remains true. Then we have nested structure. Flowchart can effectively represent nested conditional statement or loops where one is structured is contained within another one. So for the loop, is depicted using diamond. I already explained like what a diamond shape basically looks like, and it's used for the processes. So we also looked at the advantages of using pseudocode and flowchart. So I said clearer thinking, easier debugging, and better communication. So what is easier debugging? You are able to know where exactly the problem is and how you can be able to tackle it because you were part and parcel of the process for creating the solution to the problem. Then in conclusion, and best practices, start early, create a pseudocode and flowchart as soon as you start planning a project. It's better to catch problems early than later. So don't get in the middle of your code and now you don't know what basically to do because that's like going to be very difficult for you to be able to resolve at the end of the day. Keep it simple. Don't make your flowchart too complicated. Use simple, clear language and symbols. Everyone should be able to understand them. Then refine as needed. Don't be afraid to experiment. So there's no like right way to use flowchart and pseudocode. Experiment with different style and techniques to find what works best for you. All right, so that's all for the flowchart. The next thing we are going to be looking at is the computational thinking. I hope you are seeing my screen. Okay, so for the computational thinking, so we said that computational thinking is fundamental problem-solving approach that empowers individual to tackle complex challenges in the digital age. Now, what are we actually looking at when we say tackling challenges using computational thinking? So we are approaching problems not from a general point of view, but from more a scientific aspect. So there are four major components in computational thinking. So we have breaking problems into smaller pieces, identifying patterns, then design efficient solutions by creating algorithm. So in the four parts, we basically have that in the fundamentals of computational thinking. We have problem decomposition, which is you dividing a complex problem into smaller, manageable sub-problems that can be more easily solved. So when you have a problem, you don't just dive into trying to solve it. So that's saying that how do you eat an elephant bit by bit? So the same thing with programming. A lot of time you find it very complicated, not because it is, but because of how you approached it. So approach is really very important because you can make the simplest thing to be difficult, and you can also make the most difficult thing very simple. It all depends on the approach. So the second part is pattern recognition. So what are we doing at pattern recognition? Identifying common trends, structures, and relationship within data to uncover insight and create generalizable solutions, right? So now you've been able to identify from the problems you've broken down that there are ones that are similar and there are ones that are not similar. So you categorize the ones that are similar into a peculiar group, and then you split the other one into different groups. Then you now move to abstraction. So what are you exactly doing at abstraction? Focusing on the essential features of a problem while ignoring irrelevant details to develop a clear and concise understanding. Then we now have algorithmic thinking. That is where you develop the solution step by step. So in problem decomposition, we first of all divide and conquer. So break the problem into smaller pieces. Modular design, design solution with distinct interchangeable components that can be tested and refined separately. So that still takes us back to the pseudocode and flowchart. Yeah. So you are able to understand that every single process, it's actually imperative in the sense that it doesn't leave you stranded when you have problems. Like you know exactly where to go. Then we now have hierarchical thinking, right? In this step, you are able to organize your problem, you are able to organize your work into sub-problems, right? In a logical nested structure to facilitate understanding and implementation. So you might want to know what exactly the word nested is. So nested is having something put inside something, and then for like when things are in layers, that's what you refer to as nested. So like onions is nested. So from one layer, you meet another layer, you meet another layer. So that's basically what nested structure is. So pattern recognition deals with three major things. The first one is observation, second part is generalization, and then the third one is prediction. So what are you doing at observation? You are carefully examining the data, information, and solutions to identify recurrent element structures and relationship. Then, while under generalization, you identify common themes, principle, or rules that can be applied to solve similar problems in the future. Then, prediction, use identified patterns to anticipate um, anticipate outcomes, behaviors, or trends and develop proactive solutions. So, as backend developer, you must come to terms with all of these things as it doesn't just make you to know how to put codes in the computer, but it makes you to be an entrepreneur, right? You are being able to see things from the aspect of the person who you are solving the problem for and not just for yourself, and we'll be looking at that in design thinking properly. Then under abstraction, you are focusing on essential. If this one is not important, you are removing it. And then modeling concepts, so representing complex system or ideas using simplified models that capture the key characteristics. So I read a book and it says uh, simplicity is the new um, the new sorry, I think it says okay, the most complex things or simplicity is the new complex. So make it simple as much as you can. Do not try to overcomplicate things once you are at computational thinking. Just simplify it so that users don't struggle with using it. Then we are reusable solutions, developing abstract, adaptable solutions that can be applied to a wide range of similar problems. Then the final step is algorithm thinking. So the first thing is you define the problem. You see, in defining the problem, you have solved the problem halfway because concept, the how you are able to perceive the people's problem, and you are able to correctly define the problem in the direction of the people gives you more authenticity and gives you clarity as to what exactly you're solving the problem and how you will do it in order to ensure that you're able to get the attention of the users. Then design the algorithm, how you step-by-step processes of how you intend solving the problem, implement the solution, and then evaluate and refine. So there are different areas where um, computational thinking can be applied to. We have the business and finance, healthcare, and education. So um, in business and finance, we have predictive analytics, and predictive analytics has to do with futuristics event. So you are able to look at data and you can see based on this data, this and this has high chances of happening. So that's like predictive analytics. Then automated decision making process. So also deal with like data as well. Um, you are able to automate process because of patterns you've seen and because of design processes. So when there are problems that are related to that specific process which you've designed before, you can see that the answer is not far-fetched. Then the healthcare, medical diagnosis, drug discovery, personalized treatment plans, and all. And then in education, you have adaptive learning, personalized curriculum. So in school, then, like everybody has to learn what every other person is learning. But with the coming of computational thinking, you are able to tailor curriculum based on individual needs and all. So, data representation and manipulation, you do not need that part. So the next thing we are going to be looking at is design thinking. So we are going to be looking at design thinking and how you as a backend developer need to redesign yourself to see things from an angle of end users and not from your point of view. So what actually prompts your expertise to come into play is after you understood what the users actually need and then coming back to yourself by saying, okay, I won't put all of these things into perspective that this is what my users need, then you can now put in your expertise. Not that you create your what you want and go and start looking for people to fit into your solution. It makes your market to be really small and to some level make it to be futile because there are tendencies that you will not find people that fit into that at the end of the day. So what is design thinking? It's number one, user focus. Number two, iterative process. Number three, collaborative approach. And number four, problem solving framework. So what is user focus? It's saying that as backend developer, you are not just coding, but you have been able to understand from your users' pain points that this is what they need. And if you're able to create the solution based on their pain point, there is going to be high productivity and return of investment for your effort at the end of the day. Then iterative process is that design thinking encourages experimentation and continuous improvement. So iPhone, Samsung, every single year they are releasing product. That is an iterative process. So they keep improving. What you have in the last version is not the improve on it. So that is basically what makes you to be better. So you don't just develop one program and stay there. Then collaborative approach. Design thinking thrives on diverse perspectives and teamwork. Then design thinking it provides a structured approach to tackling complex challenges. All right. So next, we are going to look at like the stages or processes, as you may call it, for design thinking. So you have empathize, you have define, ideate, prototype, and test. Then the final one is iterate. So under empathize, you're basically gaining deep understanding of the user's needs and perspective. Then under define, you clearly articulate the problem to be solved. Then under ideate, you generate a wide range of potential solutions to the problems which you've discovered, just as we referring back to um, computational thinking. Then prototype is create tangible representations of the solutions, then gather feedback from users to evaluate the solutions. Then number six is iterate, refine the solutions based on user feedback. So under empathize, understanding the user, you need to do a user research. Under user research, you are conducting interviews, surveys, observation to understand user needs, behaviors, and motivations. Then empathy maps basically is the representations of what you've discovered during your user research in a way which will enable you to have a deeper insight and this deeper experience uh, based on the research you've carried out. Then we now have user journey mapping. So mapped out the steps users take to achieve their goals in order to identify pain points. So if someone is going to a long distance to fetch water, you now decide to walk that long distance. You've been able to understand the pain point of that user. So you create user journey. Okay, if someone wants to buy, let's say, uh, someone wants to buy food, for instance, you now say, oh, the person has to leave everything he's doing, go to a store, start searching for what he wants to buy, then pay for the food, start trekking back to his office or to his working place. By the time he comes, productivity has been reduced. So you can actually say this is a user journey mapping, and all of these things put in place. You can now find what are the pain points or he struggles with payment of whatever he is buying and also you can now decide to now do a personal development. That's the fourth one. So creating fictional representation of target users to understand like their characteristics. And all of this personal development would be effective if you have successfully done a user research. So every single part of the design thinking is interconnected. By the time you miss the other step and trying to jump the other step, there is every single tendency that you are going to miss out of a beneficial result. Then framing the problem. Under framing problem, you are first of all creating the problem statement, user need, and constraint. So under problem statement, you define, oh, the user is having problems with getting food early to his office. So what is his need? He wants food to be made available for him in his office immediately. So, but then what are the constraints? The constraint is location, the constraint is payment, the constraint is delivery, or there is food, but delivery process is quite high. So you are creating an app that connects buyer and delivery people, or the buyer or delivery people with sellers of food so that they can be able to get to their customers at a very faster speed. Then you are able to, so it is in the constraint that makes you to become a backend developer or yeah, whatever you are doing, you are able to create a solutions that tackle both the users need and their problems. Then the next thing is ideate. So in the ideation, you are brainstorming, you are sketching, you are mind mapping, and you are prototyping as well. Then on that prototype, you are bringing ideas into life. So, uh, you have been able to on that prototype, we have what we call the MVP, right? So what is MVP? MVP is the minimum viable product. So, a product where a user can actually make use of without sorry, a product that can actually solve the user's problem at a minimum stage. So before adding all of the aesthetics and all. So you can have sketching, paper prototyping, digital prototyping, or video prototyping, anyone. So in order to elaborate on the concept of prototyping, you could like use the Wright brothers. When they created the first plane that flight, of course, it can't carry passengers, but it could actually fly. So you can refer to that as a prototype. Then the last part is testing. So under testing, we have the user testing, observe users interacting with the prototype and gather feedback. Then we have the A/B testing. A/B testing is you are having version A and you're having version B. Now you're comparing both version A and version B to see like how they are doing in the market space. So that's for the A/B testing. Then survey is that you are able to gather feedback through questionnaires. Then iterate, refining the solution. So you have user interface, user experience, and functionality. So refine the user interface based on user feedback, then user experience, improve the overall user experience by addressing pain points identified during testing. Then functionality, ensure that the solutions meet user needs and solve the problem effectively. So design thinking is not just something you want to just go by. I would strongly advise you also do your in-depth research, as it's just not going to help you in software or back-end development, but even in your general life. Thank you. To have a wonderful day.